Very good morning, one and all. Today, we are going to see a problem on superposition theorem. Take down this problem. Find the voltage across 1 kilo ohm resistance by using the superposition theorem. So, this is the circuit diagram. So, here you are having the three sources. One is one current source and another two voltage sources there. Rest are all resistances there. Here, our main motto is to find out the voltage across this 1 kilo ohms by using the superposition theorem. So here, what superposition theorem states? Superposition theorem states that in any linear network containing two or more sources, the response in any element is equal to the algebraic sum of the responses caused by the individual sources acting alone, while the other sources are non-operative. So, in detail, this superposition theorem steps are being explained in our previous class itself. I'll give you that link also in the description. So if you want to refresh, once you refresh and come to this problem. So first one source, we need to take one source is acting alone, other two sources is not acting. So by taking 10 amperes, that is 10 milliamperes current source acting alone, other two sources, other two voltage sources, what we are doing is we are short circuiting. So short circuiting the voltage sources, other two voltage sources. So redrawing the circuit. So here 10 milliamperes is there. Here 4 kilo ohms is there. Here 1 kilo ohms is there. So this voltage source is short circuit. This voltage source is short circuit. So this is short. This is short. Okay. So here one more 5 kilo ohms is there. So after short circuiting this, so current will always, so current source is coming from this and flowing like this. So current will follow always the low resistance path. So this 5 kilo ohms will not have much impact. So just we are neglecting because current will come like this. So it will not flow through this 5 kilo ohms because it is short circuited. So it is current will always follows the low resistance path. Okay, so now we are redrawing the circuit. So 10 milliamperes, 4 kilo ohms. So this 1 kilo ohm is in parallel. Okay, so 1 kilo ohm is parallel with this. So now we need to find out what is the current through this 1 kilo. So current through this 1 kilo ohm is nothing but by using the current division rule. So opposite resistance, that means opposite resistance 4 divided by 4 plus 1 divided by total resistance, that is 4 plus 1 kilo ohm into this current flowing in this particular set. So 10 milliamperes. So 4 divided by 4 plus 1 is 5 into 10 milliamperes. So it's nothing but 8 milliamperes. So now we need to find out what is the voltage, because in the circuit, the problem itself, they asked what is the voltage across. So voltage across 1 kilo ohm is equal to, so V is equal to I into R. So I is 8 milliamperes. That is the current flowing through this 1 kilo ohms into resistance. The resistance is 1 kilo ohm. So 8 into 10 to the power minus 3 into 1 into 10 to the power 3. It is nothing but 8 volts. So 8 volts is the voltage flowing through this 1 kilo oops. Now, next one, by taking 25 kilo, by taking 25 volt voltage source acting alone, other current sources open circuit and short circuit the voltage source. So here in this circuit, only one 25 volts voltage source is alone acting alone. This is short circuit. This is open circuit. Okay. So now redrawing the circuit again. So if you redraw the circuit, it will come like this: 4 kilo ohms, 1 kilo ohms. So here voltage is 25 volts, here is 5 kilo ohms. Now it's very simple. Okay, so here so 4 plus because we need to find out what is the current to this 1 kilo ohm. So for time being, what we are doing is we are just making this because this two in series. So we are just clubbing up and making it as 5 kilo ohms. So 5 kilo ohms, here 5 kilo ohms, just to make the problem easy. So here two 5 kilo ohms are there. So two resistors are in parallel, means the total equivalent resistance is that particular resistance divided by 2. So 5 kilo ohms divided by 2 is 2.5 kilo ohms. So So what is the current flowing to this particular 25 volt is nothing but, so I is equal to V by R. So V is 25 divided by R is what, equivalent resistance is what, 2.5 kilo ohms, because here 5 kilo ohms, here 5 kilo ohms, so 2.5 kilo ohms. So 2.5 into 10 to the power of 3. So if you simplify, you'll get a 10 into 10 to the power of minus 3, that is nothing but 10 milliamperes. So 10 milliamperes is the current flowing through this. So if the current flowing through this from the 25 kilo ohms, it is divided into two. Okay, that is here 5, here 5. Why here equally 5, 5 means here 5 kilo ohms is the 5 kilo ohms. So current will be divided equally. So 5 milliamperes, here 5 milliamperes. Okay, so here the current to 1 kilo ohms. Now you just make it here 4 and 1. So here the current to 1 kilo ohm is nothing but 5 milliamperes only, because here 5 milliamperes means, so here 5 milliamperes, the current is 1 kilo ohm also 5 milliamperes only. So here the current to 1 kilo ohm is 5 milliamperes, but it is in reverse direction, because the current, the voltage source is here, it is flowing like this, so it is flowing in reverse direction. You can also write as minus 5 milliamperes also. Okay, but it is flowing in reverse direction, that you keep it in the mind. So here you, what is the voltage across this particular 1 kilo ohm is nothing but, so V is equal to I into R. So I is what, 5 milliamperes into resistance is 1 kilo ohm. So here minus 5 into 10 to the power of minus 3 into 1 into 10 to the power of 3. That is 1 kilo ohm. So if you simplify, it is 5 volts, but is in reverse direction. That means minus 5 volts. Also you can take. So always remember, this is in reverse direction. Next is what? By taking the 15 volts alone acting, 15 voltage source alone acting. Okay, so if you go to the main circuit, if you see here, here now this two completed already. So here only 115 ohms alone acting alone. This two, this is short circuit, this is open circuit. So redrawing the circuit. So this is open circuit, so no use. Okay, so here this is short circuit. So now again we are redrawing the circuit. How? So here 4 kilo ohms, here 1 kilo ohms, here 15 ohms, and here 5 kilo ohms. So here you see, the here it is short circuited. The voltage source will supply like this. Okay, so the voltage source will supply like this. So here 15 volts is there. The voltage sources will be supplied like this. So if it is short circuited, this any current flows to this 1 kilo ohms. No, it is zero, because you see the current will always follow the closed loop path. So no current will flows to the 1 kilo ohms, because here short circuited. Okay, so here short circuited, no current flows to the 1 kilo ohms. Okay, so here the current to the 1 kilo ohm is 0 amperes, and also if current is 0 means voltage is also 0. So voltage is 0 volts. So V triple dash is 0 volts. So the voltage across 1 kilo ohm is nothing but V dash plus V double dash plus V triple dash. But why we are taking here is minus means, because the voltage is supplying like this. Okay, in opposite direction. The voltage is supplying in opposite direction. So we are taking this as minus 5 volts. Okay, so that you remember. So here 8, V dash is what we calculated. V dash is, here is 8, here it is V double dash is minus 5, and here V triple dash is 0. So if you simplify, you will get the answer as 3 volts. So voltage to 1 kilo ohm is 3 volts. Okay, so this is the answer for this particular circuit shown in the figure. Okay, so voltage to 1 kilo ohm through the superposition theorem is V dash, V double dash, that is 3 volts is the voltage to this 1 kilo ohms by using the superposition theorem. Okay, so very simple problem. The thing is, the simple logic you need to apply, and you need to solve this problem.